In today's video, I'm going to have a look at how we can use the compound interest formula to calculate the future value of accounts, as well as the total interest earned over periods of time where we've got different compounding periods that aren't necessarily annually anymore. But to get started, the formula that we use to calculate compound interest is the FV equals PV bracket 1 plus I over K, close the bracket, all to the power of K times N. Now let's start to discuss what these different values actually represent. So our FV here stands for future value, which is how much that we will have in the account at the end of the investment period. Our PV stands for present value, which is how much we're going to invest, or if it was a loan situation, how much you're going to withdraw from the account at the start. Our I here is the interest rate. And when we're using this formula, we represent this interest rate as a decimal rather than a percentage. And our K here is the number of compounding periods that we have per year. And I'm going to talk about that in a little bit more detail in a moment. But our N value here is the number of years that we are making our investment. Now, it's this K value that's very special because when you're looking at interest rate accounts, it's not very often that we find that the interest compounds annually. In fact, it's more frequently that we find it to be compounding more regularly than once per year. So, depending on how often an interest rate account compounds will depend what our K value is. But there are 7 compounding periods that we should remember the K value of off by heart. And they are as follows. Obviously, the first compounding period that we can have is annually. Now, if we're representing our K value for a compounding period annually, it means that the interest is going to compound once per year. So our K will be equal to 1. The next common compounding period is half yearly, which means the interest is going to compound once every half a year or twice per year. So our K value will be equal to 2. The next common one is quarterly, where the interest will compound once per quarter, and there'll be 4 quarters every year. So our K value will be 4. The next common one is monthly, where the interest will compound at the end of each month. Now there are 12 months in the year, so our K value will be 12. The next common one is fortnightly, where the interest will compound at the end of every fortnight, and there are 26 fortnights in a year, so our K value will equal 26, which brings us to then weekly, where there are 52 weeks in a year, so our K value, if it's weekly, will be 52, which then brings us to daily, where there are approximately 365 and a quarter days in a year, but we don't worry about that quarter of a day. So our K value will be 365. Now that we've discussed the different values that K can actually be, let's have a look at the following problem so we can apply this formula and see how it works. Where $5,000 was invested into a compound interest account at 6.1% interest per annum compounding quarterly. We want to know how much total interest is earned after 5 years. Now with these types of problems, I always like to work through each variable that I have in my formula to work out what information I do have and what information I need to find. So in this case, our future value we don't currently have. We do have our present value, but we don't know what our future value is. So that is a question mark. Our present value though is that $5,000. Our interest rate is 6.1%, but we need to represent that when we're using in this formula as a decimal, so that's 0.061. Our K value, well, we found that it was compounding quarterly, and if we look at our quarterly, it's going to compound 4 times per year, so our K value is 4. And our N value is the number of years, and we're investing it over 5 years. So now, what I can see here is I've got all the other variables except for our future value. So my starting point will need to be to work out what my future value of the account is, so then I can work out how much total interest will have accumulated in that time. To do that, I substitute all my values into the formula. Then, once I've done that, I can use a calculator and input this formula into my calculator to solve for my future value. And when I do that, I find that my future value is approximately equal to $6,767.53. But this will actually tell me what my future account balance is and not how much total interest has been earned over that period of time. To do that, I'll actually need to do one more step. And that is to calculate the interest. To calculate the interest, I need to have my future value here and subtract my present value up here. So my total interest will be my future value of $6,767.53. Subtract my present value of $5,000. So therefore, the total interest is approximately equal to, and I've got to make this approximately because I did round in this step up here, but it's $1,767.53. So when using this formula to calculate compound interest over different compounding periods, you first need to identify what information you do have and work out what you're actually trying to calculate. The K value is something that is new, and that's how often it's actually compounding every period. And depending how often it compounds will depend what our K value actually equals. Once we do have all our information, we want to substitute our values into the formula and then solve for the variable that we're looking for. Often we're wanting to start by solving the future value. But if we actually want to know how much total interest is generated over that period of time, what we'll need to do is an extra step where the interest is equal to the future value, which we've calculated in this step, subtract our present value, which was 5,000 in this step. And that'll give you the total interest that would have accumulated over that period of time.